Well, it looks like it is time to get started. As you can see, David is sharing things. David, do you want to start us through the slides since you've got control?
Sure, yeah. Let me, oh no, because there's the chat windows actually cover the controls for the PDF, so that's unideal. Okay, so good morning, afternoon, evening, middle of the night, everyone, and welcome to DNS Service Discovery. My name is David Skenazy, and our other co-chair is Barbara Stark, and we're going to talk about DNS.
David, I'm going to interrupt just for a moment. In the chat window, you click the little box that says detach chat, and then you can move it into a window anywhere on your screen that you like, just as God intended.
That's exactly what I've done. You can't do that with individual one-on-one chats, though. Those pop up from the bottom. No worries. Okay. It's a good tip. Thanks for that. Yeah, it's no, and we're also using the new Meet Echo feature to share slides, which means that presenters will be able to control their own slides. No more next slide, please, without anyone having to share their screen. So this is pretty neat. All right. So given that it's the second day, I hope that folks are familiar with the note well. If you are not, please use your favorite search engine to go find it and read it. It defines all the rules for our engagement here at the IETF. In particular, when you come to the microphone and say things, that has implications if you know about any patents related to it. And also it shows the code of conduct under which this meeting operates, which pretty much says be nice to everyone and everything will go well. But if you haven't actually taken a look at the text of the code of conduct, you really should. Otherwise, in terms of trivia, here are some links if you want to follow those. We'll be looking for someone to take minutes, please. Can anyone volunteer for that today?
Be there helping out, taking the minutes, so it wouldn't be like someone all by yourself, but help is appreciated.
In the absence of anybody else volunteering, I will do it.
Thank you.
Thank you very much, Stuart. All right, and so the Jabber is being forwarded to the Meet Echo messages, so I'll keep an eye on it myself. If you want to say something there, just say Mick : and I'll relay it at the microphone. As a reminder for everyone, we have a GitHub organization, and it is completely open for any working group documents, so just reach out to the chairs if you want to move a document over there. And here is our agenda for today. So we're going to start with a presentation by Torlis on compatible service discovery in generic autonomic signaling protocol. And then we're going to have a set of presentations from Ted Lemon over a set of drafts. And then we'll keep the order of 10 minutes at the end to wrap up. Would anyone like to bash this agenda before we start? All right, hearing no objections. Torlis, you are up. Please, I'm going to stop the slide share. Please click the request to share slides on the top left next to sharing camera and audio.
Right, and you want me to share the slides from my computer?
No, so if you just click the request to share preloaded slides, the one that's a piece of paper, not the one that's a screen, it'll actually share them directly from the Meet Echo, as opposed, you don't even need to share your screen. And, okay, you clicked it? Yep, let me grant that.
There it comes up, yeah, you need to approve, yeah.
And then there should be 3 sets of slides, so if you just select yours.
Right. Okay.
All right. It looks like everything's good. Go ahead. Thank you.
So this work was already presented to Dnssd eternities ago, before Corona, IETF 100. We let it expire because we had to finish our charter round 1. This wasn't charter round 1, so we're now reviving it after we did our charter round 1, and so there's very little editorial changes. We got the new co-authors on it, but I wanted to bring it again to the attention to Dnssd, to look for interest, possible collaborators, and certainly, you know, later on reviewers. So the basic thing is that we have, you know, our new good tool for our use case is a transport mechanism for flooding, which is GRASP, and signaling mechanism. So we want to have, you know, Dnssd compatible service announcement and discovery. So that's supposed to be, you know, at the API level, so that hopefully one and the same API could, you know, depending on deployment, which network it's trying to do it into, use GRASP with Dnssd, or, you know, any of the existing ones like 67, 63, and that basically is kind of the goal. The way it would look in GRASP is that's a very simple, you know, messaging protocol based on CBOR. Here is basically how a single GRASP service would be defined in the definition language. CDDL has typically, you know, all the known parameters that we have in Dnssd, except that they don't need to be split up across at least 4 different type of resource records as the mapping to DNS requires. So it's, you know, in the implementation on the wire should be a lot more simple. The prototyping code that Brian Carpenter did, I think, already pointed to that simplicity. Yeah, that was basically the pitch. If there is any more time left, I can explain a little bit the use case and how basically that would be used in Anima. You tell me.
You do have some more time left.
That's good. And Toys, if you want to manage the queue, I think it looks like Stuart has a question. So just
okay. Sure, please just go ahead.
If you could go back to the previous slide, I had a trivial question in the example. You give service name printer. Does that? I'm trying to find the RFC number. Are those service names managed by IANA in the standard service?
That was actually on the later slide. Yeah. So the idea would be exactly to use the existing services registry. Yes.
Okay. It's RFC 6335.
Yeah, I said up there.
So if it's following that syntax, then it's for good or bad. It's what we inherited from the SRV format. It's _printer_TCP.
Right. So I think that I considered that to actually be part of the mapping, right? In the service registry, it just says printer, and then the Dnssd thing says, you know, convert that word printer into _printer.udp. something. I think that's in a later slide. The service registry on IANA doesn't say .udp. something, if I remember correctly.
Okay, just as long as we're clear about that. Yeah. There are some protocols that define a TCP and a UDP variant that are not the same. If I could go back in time, I would erase that, because that was, I think that was a design mistake in the original SRV specification, that the service string has to reflect the construction of the protocol and what protocol it runs over. But unfortunately, that ship has sailed, so we're stuck with that boilerplate text. And of course, in a compact encoding, you can omit the leading underscore, because that's kind of bogus, and you can compress the UDP or TCP down to a single bit, just as long as we're. But you answered my main question, which is, we're not inventing yet another registry of service types. Thank God.
Exactly, it's the opposite. Ted?
All right, thank you.
Yeah. So is the idea? Sorry, is the idea to have this go to some kind of translation server that then does a Dnssd query, or are you proposing to replace the Dnssd protocol?
not the well, the DNS, as I said, right? So to me, this is yet another way to provide the service, and we don't need the Dnssd unicast or Dnssd multicast or mapping of the service information into its SRVs, because GRASP is its own transport. Right. So this was basically what the picture was trying to show.
Okay, so in other words, you're inventing a new protocol to do the same thing as the old protocol?
No, we already had the new protocol invented, and I was trying to say that we don't need to duplicate things in there that we already have, and that is specifically the definition of services and the registry for it. And that's basically what I call the DNS service API and registry. I'm not sure that we actually have anywhere a real specification of even the abstract DNS as the API. You kind of have got to reverse engineer that from 67, 63, which is very instructive of how to map it, the service definition into these 4 different resource records, sorry. Right, so maybe I should also try to write a chapter of saying what we consider to be that abstract service API, that DNS. But you can see the concrete instantiation, of course, in various DNS service libraries, Dnssd service libraries.
So yeah, I noticed that you kind of sort of have the equivalent of a DNS service resolve in the API that you showed. Does that make sense to you?
Well, I mean, what I'm showing here is primarily only the all the different parameters of interest, and then I left out kind of the objective command, like in terms of announce or discover or so. That's on another slide that I don't have in this deck.
Okay.
Right. But the whole point was that, I mean, we actually, our industrial pre-standard Anima implementation was using MDNS, and so there is a lot of experience from that, and why it's not really the best way to do things. So for the standards, that was also one of the starters while we're doing this with this protocol. So the actual Anima use case is really that we're building this autonomic network. So you plug the devices together, you get an invent, a secured virtual network for all OEM instructions. So that's where we are in the IETF. And the piece that we're missing is now how do we discover and announce services for the infrastructure itself. So the typical examples are syslog, radio servers, diameter service, NTP servers, all these things, of course, we want to automatically configure. So it's good enough for you to bring up a server and basically, automatically or manually say, what's its priority weight, all the good DNS things, and then it should be discovered there. And the interesting part is that this whole ACP works without names, because every node gets through its certificate a lifetime IPv6 address. And that basically means even the whole naming stuff that's also in Dnssd isn't necessary at all. We can simply resolve between the service and the IPv6 address in the ACP, providing further simplification. Yeah, this was the list of the services that in another draft I've explicitly listed as how to bootstrap a network, right? So those are the most important ones, but there's obviously a wide variety of other services I list on the last line for centralized or decentralized service instances. Maybe this is kind of the details why I hate MDNS multi-hop flooding. I don't want to go into details of that. That takes forever. But I think and the GRASP stuff also maybe.
Yeah, everybody hates DNS multi-hop flooding. There's no argument there.
Right. Okay. So what we're doing is actually we're having a message identifier, and we're doing loop prevention by having a cache of recent messages. So that's how we can flood very efficiently without looping. So this was the registry, right? So the whole thing started that we had our own namespace, and it may still be useful whenever what we're doing with GRASP has nothing to do with the service that we announce and discover. But then we started to do things like we needed to have EST, which is RFC 7030, which already is in the services registry, and we would redefine it. So the proposal of the current draft is now to have you know, in our name, a similar mapping as, you know, so we're doing srv dot existing service registry name, which would be similar to the underscore, so to speak, in DNSSD. And maybe just to wrap up, so yeah, so there's prototype for this, and maybe the interesting things for the group to consider to look more into it is this ACP stuff that we're doing is fairly convoluted and complex because it is secure with certificates and everything. But if it's just about using GRASP to have a you know, network-wide multi-hop flooding mechanism of messages that could then be used for service discovery of services where you really don't want to have a third party, right? So every DNS unicast server is a third party dependency that needs to run between the service announcer and the consumer. And, you know, we didn't have that in the original layer 2 networks, right? But in layer 3 networks, it would also be nice to have something without that third party. I think it would be fairly easily possible to define an adoption of GRASP that could be easily deployed in every existing network, not only in Anima networks. And so the last 3-4 bullet points there give some direction. So maybe if this overall sounds interesting, but is saying, hey, I don't want to have the whole Anima stuff, talk to me, and we can, you know, think about, you know, what the lowest hanging fruit would be to get this adopted in any type of layer 3 network. All right.
Thank you very much, Carlos. Are there any other questions or comments before we move on to Ted's mega presentation? And so discussion of this one specifically, this draft specifically that you just saw from Torlis is going to be happening in Anima. There is his offer that if you have interest on expanding use of that to more generic use cases beyond Anima, you can contact him. Thanks. Ted, are you prepared to share, or, well, to click the appropriate buttons to start the slides appearing?
I am prepared to click the button.
So you are, oh, there we go. Access granted.
Okay, so a very bold statement for the talk. Basically, we've been doing a bunch of work over the course of the life of the working group to kind of extend the different use cases and sort of solve problems like the one Turles was alluding to with multicast flooding, which is not something we like. So I just want to go over kind of where we are and where we're going. A bunch of work has occurred, and I think I hope it's of interest to the working group. So first of all, you know, what is Dnssd? The whole idea with Dnssd is an automatic advertising and discovery of network services, permissionless, can be managed, doesn't have to be. It's built on top of DNS, and that's because DNS is also an advertising and discovery service. So we're basically just making DNS better. So how it works, some devices provided services. They advertise those services using PTR records. PTR records are, you know, there'll be multiple PTR records if there are multiple services of the same type. And so you can just do a query, get a list of PTR records, and all of those devices provide that service. And then you can do a resolve to get the information about the service. That would be the SRV record. There's also a TXT record, which has additional information about the service. And then once you have the SRV record, you can also look up the IP address of the device. I swinishly used an A record instead of a quad A record. I apologize. So that's how you publish services. And then a device that wants to look at services or find a service first does the discovery by looking for the PTR records, and then it selects a service by choosing one of the services listed in the PTR records, possibly through configuration or whatever. And then, or, you know, normally it would be the user touching it, but that's only if it's not automatic. And then once the service has been chosen, it resolves the service by looking up the SRV record. And once it's looked up the SRV record, that tells it what quad A record or A record to look for. And that's all it needs to know to talk to the service. So as of about 2018, there were kind of two ways of doing Dnssd. One of them was to multicast DNS, which is, as I said earlier, permissionless. It's limited to a single subnet, so it's great for like a home network that only has one subnet. And this is documented in RFC 6763. That's the Dnssd specification, and RFC 6762, which is the multicast DNS specification. So that's work that's already complete, obviously. Unicast DNS, very similar. Really only works for managed networks, so there's no automatic way as of 2018 to do unicast DNS. And the nice thing about it is it's not limited to one subnet, so you can have like a whole, campus with services that are discoverable across the campus. And this is documented in RFC 6763 again. That's the core Dnssd document, and it leverages RFC 1034, 1035. So I realize this is all review, but I just want to kind of set the stage. So the idea with Dnssd over MDNS is you have all these devices, and so say device A wants to discover a service hap.tcp, it sends a multicast, and that reaches all of the devices on the network. And then those devices that support hap.tcp, which in this case is only device B, respond with the information. I'm oversimplifying. I mean, normally it would be a PTR record, and then the response with MDNS, the response from device B would be a PTR record with a whole bunch of additional information, which would actually tell you everything you need to know if you select that service. So you probably have the A record or quad A record or both. You'd have the TXT and SRV records as well. So it's basically it's a single packet exchange for the most part. So then with Dnssd over DNS, it's a little different. The DNS server just has a database in it. None of the devices do anything. Somebody has configured the DNS server with the databases, and then device A wants to discover, the same sort of service, and it basically does the same set of queries. It's a little less likely that the additional section will be nicely populated in this case. You could have a server that's kind of set up to know that you're going to want that information, but normally that's not going to be the case. So you're going to have to probably do an A record query. Sorry, you're going to have to do a PTR record query. You'll get back the list, and then you'll do an SRV record query for the one that you want, and a TXT record query for the one that you want, and then you'll start doing quad A or A record queries. So so it's a little bit clunkier in that sense, but it's also, I mean, it's unicast, so the cost of sending packets is low, and it's not really a big deal. Oh, right, and there's your answer. So then in 2019, I mean, we've been working on this for a long time, but these were basically finished in 2019. We added the Dnssd discovery proxy and DNS push. Dnssd discovery proxy gives us the ability to do, instead of doing cascading multicast, which as Turles pointed out is kind of crappy, what we do is we have single subnet multicast for discovery, and then these discovery proxies act as authoritative DNS servers for specific zones. And so we do queries into those zones to get the information using, at the far end it's MDNS, but all of the queries are done with DNS. DNS push adds the ability to do those queries asynchronously. So one of the nice things about MDNS is you send a multicast packet for services, and you just kind of keep sending it every so often, and you'll get back new information. And also, as services come onto the network, they'll announce that they've come onto the network. So when a service shows up, it just shows up in the dialog box or in your, in your little internal list or whatever. And the problem is DNS, regular DNS doesn't have that ability. DNS is just, single packet exchange. So so DNS push added the ability to say, okay, I'm going to connect to the DNS server, and I'm going to ask it to tell me whenever there's new information about records that match this question. And that lets us say, give me answers for hap.tcp. whatever the domain is, and we'll get back SRV records as services register. So that's really nice. So the way that looks is the discovery proxy, the device that's doing the query sends the message to the discovery proxy. The discovery proxy then multicasts on the local net. Notice that device A is on a different net than all the other devices. The device that actually has the answer responds, and bam, we got a DNS answer, and it's over DNS push. So now if some other device, see device F shows up, it sends a multicast announcement saying, hi, I also do hap.tcp. And then bam, we get another DNS push answer going out to the device. So it's nice. It implements the same sort of functionality as we got out of MDNS. So I think I probably covered this slide pretty well. So that was great, but you might have noticed that we added some new stuff. That was SRP and the advertising proxy. And the idea with SRP and the advertising proxy is that multicast kind of sucks on constrained networks because every device winds up getting every question. And these are devices that have batteries in them. You don't want them to be sitting there all the time listening for queries. And the other issue is that the constrained networks are usually not the same network as all the rest of your stuff. So if you've got like, you know, an iPhone or an Android phone or something like that, and you want to discover all the light bulbs in your house and they're all on some constrained network, that's going to be a different network. So we thought about using a discovery proxy, but we didn't want to use multicast. And so we decided that what we really wanted was a stateful service, kind of like DHCP, except sort of backwards. So the idea with this service is that you just announce to some central service, I offer this service, and then the service just keeps a database, and anybody who wants to ask questions about what's going on, what services are available on this constrained network, just talks to that server and doesn't have to do any multicast onto the constrained network. So so the two drafts that do that are the SRP draft and the advertising proxy draft, which I'll talk about a little bit more. So the way this works is you have a device, it sends an SRP update to the SRP proxy, and then later on another device wants to find out about devices, the services of that type. It asks an MDNS question, because this is an MDNS proxy, and it gets back an answer. And we wanted to use MDNS in this case because we wanted devices that already work to just work. We didn't want to have to do anything special. We didn't want to have some kind of infrastructure to support this. So I kind of rushed to this point because this is the most important slide I think right now. Draft SRP replication 10 is ready for last call. We had comments on the document, but they kind of petered out. We got lots of good comments and lots of changes based on the discussion in the working group. But the last comment was, oh, you know, you don't have a way to deal with alternate services, and there's some stuff in RFC 6763. If you didn't follow it on the message on the mailing list and you're curious what that is, talk to me. But basically, the idea is that you can say, you know, that a device provides, you know, you can alias services. So I just added some text to the document to do that. Basically, as far as I can tell, the document's ready. I mean, if we do a last call, I'm not even convinced that there's going to be further requests for changes at this point, although I'm open to that if there are requests. So I'd like the working group to do a last call at this point. One thing that I noticed when I was preparing for this is that we have a normative reference to a document that we never adopted. Draft Sakar DNS UL is the something lease option. I'm blanking on the name. Stuart's going to tell me.
It's UL stands for update lease.
Update lease, thank you. Yeah, so basically it's saying how long the SRP update is good for, because we don't want it to be clogging up the network database forever.
It was named that way however many years ago it was, because it was a companion to standard DNS update. When you update records with NS update, they stay there until a human comes along and deletes them. And we wanted this to be a bit more suitable for machine-to-machine communication, kind of modeled on DHCP, which is if you don't renew it, it goes away when your lease expires. So that's why it's called an update lease.
Okay, so you have some requests here. Let me ask the working group, does anyone have any reason why we should not start WGLC for the SRP replication? Is that the right one? Yeah, SRP. Yeah, that's what I thought.
SRP. It's not
all of a
SRP
sudden I'm like,
replication.
we did the replication. So SRP.
No, it's not that one. That's not ready for last call at all.
I'm not seeing anybody step into the queue. I'm wondering if I'd like to kind of get a sense of how many people are ready to and willing to review this, if that's okay, just to, get some commitment here in the meeting. So can we do a show of hands willing to review SRP? Okay, I've started this. Can I just get a quick show of hands of who's willing to review the SRP?
Sounds like Stuart's in the queue. Do you want to say something, Stuart?
I want to say that I clicked
Okay,
the wrong button. I
so
was trying to
I
show my
see
hand, but I clicked the wrong hand.
3 people have raised.
Hang on, I can't find. I know this always confuses me with Meetup. Where am I supposed to click?
Yeah, there's a show of hands tool. It's kind of in the center of all those big icons on the top. It looks like a bar chart for some reason.
It's turned yellow because it's turned on. Okay,
Yeah, so you should click on that and then click on willing to review. I hope that
Yes.
more than 3
Okay.
people are
So
willing to
with
review.
the
Although,
explanation, the
to be
number
fair, a
has
bunch
now
of people have
increased to
already
5.
reviewed.
Okay. So yes, let's start at WGLC on this, David. We will do that. Okay. Your other
Okay.
question, Ted, was a call for adoption of the advertising proxy for Dnssd. Okay.
Yeah. Right.
Okay.
Yeah. So that's the bit that
we ended
does
up
the
with the
most
6
advertising
people
of
raising their
SRP
hand.
stuff.
That's good. Okay, so let me start a new one. And of course, this gets confirmed on the list. And I'll start that. But I do want to see, get some sense of the room. We have 50 people in here. Okay.
The poll, I'd like to take a quick moment to give some background about why we believe this is important. This is not just a little academic exercise to design a useful protocol because we think it's useful. This is being used in Thread, which is a low power wireless mesh network, which is in turn being used for home automation in the new home automation protocol coming out, which was previously called CHIP from the Zigbee Alliance and has now been renamed to Matter, M-A-T-T-E-R, and the Zigbee Alliance is now called the CSA. So there's been some name changes. And we are already using a precursor of this in the Apple HomePod and the Apple TV to support thread-based HomeKit accessories. And these are little battery-powered devices that run on a half AA battery for 2 years. So that's why the stuff that Ted said about power efficiency is super important. If we were pinging all these battery-powered devices with multicats all the time and they had to be listening for them, we would kill the batteries in 2 weeks instead of 2 years. So this has big impact on the home automation industry.
So while you were talking,
and hopefully in all of our houses in a couple of years' time.
Well, let me just
way,
finish up this.
nothing that
Okay,
Stuart
while
said should be
Stuart was
taken-
describing
Sorry,
that, he
go ahead.
apparently convinced everybody. Well, at least there are 7 hands raised, and there are no people who purposefully did not raise their hand, which would be the, I guess, the hum opposed. Well, now that you know that, you can, if you purposely want to not raise your hand, you can oppose. But it looks like there's certainly enough for us to start the call for adoption, and if there is opposition, you can voice it there. So we will start the call for adoption. Okay. And you were about to say something about Stuart.
Thanks. Then, Oh, I was just going to say the fact that that exists in a product should not be taken to mean that we're wedded to doing things exactly the way it is in the product, because we're not. We can do updates. So that said, the last thing is draft to car is a really short draft. It just explains the update lease option, and I'd like the working group to
so you're
adopt that
saying
because if we don't, we can't actually publish the SRP document.
If you're looking to volunteer to review a draft and you want to do the least amount of work, reviewing that one is probably a good candidate.
Okay,
Yeah.
so let me understand what
You can say I read the whole
I
thing
was
thoroughly.
Okay, so we're going to start working group last. Sorry.
All right. Just allow me to interrupt a few things. I have to read the second draft to understand the content, but we need to be sure it fits the Dnssd charter before adoption.
I mean, we can't do SRP without it. It's
Or it can be a normative reference outside of the Dnssd. It could be AD sponsored or whatever. My only question is whether it will be a Dnssd document. That's on this.
Yes,
It
I
was
think
a
I
value,
agree
right?
with
I-
Mike that it could be DNSSD or it could be DNSOP. Yeah, we should check.
Exactly.
I agree 100% with what Eric said, and Eric also mentioned AD sponsored as an option. So I think
Right.
that the right way to answer this question, as Ted said, it is really short. It is basically you do a DNS update and add an EDNS0 extension, giving a lifetime in seconds, I think. And it's modeled on DHCP, where the client requests something and the server grants a lease, which may be more or less than that. If we decide it doesn't fit within DNSSD, and arguably it doesn't because it's a generic extension to DNS update, then AD sponsored, I think, would be a totally appropriate way to move this along. It's not complicated, it's not controversial. It has been in use since about 2005. We ran out of steam pushing it through the IETF standards process. So time to resurrect that and finish it off.
We agree.
okay.
Okay,
shall,
so let
shall
me.
Oh,
Oh,
sorry.
go ahead, David. No, go ahead.
I was just going to ask if I should continue, but it sounds like you've got more to say, so that I shouldn't continue.
Trying to summarize where we are. So to summarize, we're going to start a working group last call for SRP, Service Registration Protocol. We are going to do a call for adoption for the advertising proxy for DNSSD SRP. And then I am going to admit that I got a little bit lost on the other document we were talking about for potentially having AD sponsorship.
So I think the chairs need to huddle on that last one with our friendly AD to see if we think this matches our charter, and then if it does, then it sounds like a good candidate for for adoption. If it doesn't, then we can discuss if our friendly AD wants to AD sponsor this, or if we should bring it to a different IETF working group.
Or
Just a
recharter.
quick summary.
Take an action. I'm sorry, Eric. Can you say that again?
Or you did a pretty good summary.
Thanks. Okay, so well, the chairs will take that action item to follow up with our AD after the meeting.
And if people in the working group do have time to review it, comments on the list would be helpful to answer this question. But if just broadly people say this looks sensible, this looks a terrible idea, that will help Eric make an informed decision.
I agree. Ted, could you email the list with asking people to review this document? And that way we'll have one good place to collect responses, and that'll inform the chair's discussion.
Okay.
Thank you.
And while my mic's live, I have a request for you, Ted. Let's update this slide to put the right draft title, because otherwise this slide will go into the meeting records and be confusing.
Okay, chairs, if I send you a new copy of this slide deck, can you still upload it?
Yep. Well, you can actually upload it yourself to the data tracker, and we'll just need to click the approve button.
Okay, I'll do that. Cool. All right, we should probably move on. We're running out of time. So, of course, when you deploy new stuff, you run into problems, and we ran into some problems. One of the problems we have, particularly in the HomePod / Apple TV deployment scenario, where these are devices that you just add to your network, completely without thinking about network management or anything like that, is you kind of want to have multiple servers for redundancy, but if they don't cooperate, you're going to get name conflicts, which we've experienced. That's one issue. The other issue is, if you've got like 50 light bulbs, then when you do a DNS query looking for PTR records to describe the light bulbs and so forth, you're going to get a really big answer back, and that's a lot of MDNS traffic. It's really not efficient to do that with MDNS. You'd really rather do that over TCP, like say DNS push. So I mean, it'd be fine in principle on wired networks, but most people are using Wi-Fi, so that would be fine, is not particularly applicable. We did some new work this year. I came up with a replication protocol that allows multiple SRP servers to cooperate with each other to share their database, so that when one server gets an update, it reflects that update to all the other servers, and so essentially it means that we don't see conflicts, because if there's an issue where the SRP client connects to a new server, we're going to get a new communication. That communication is secured with the same key that was used for the previous update, and so we know that it's the same client. And so, and the fact that it's more recent means that it's more recent, and so we can throw out the old information and use the new. So it's a nice little protocol. It turned out that SRP was a pretty simple thing to do replication on, as compared to all the other things we do replication on that are a lot harder. At least that's my theory. It'd probably be good if the working group checked my theory. And then the scalability thing, basically the solution to that is something that's actually described in RFC 6763, but RFC 6763 doesn't give much detail. So I wrote a document along with Joey Deng, who's a coworker of mine at Apple, and that document describes, Joey did most of the implementation on this. That document describes a mechanism for advertising the availability of a DNS authoritative server for an ad hoc zone into which you can do queries using DNS push to get answers about services that are available on the network, rather than using MDNS. And so that's a work in progress. It's still pretty young. I think it needs a lot of discussion. I think this is the right place to do that discussion. And so I'd like to do that. As I said, I've written, or I don't know if I said, I did say, I've written drafts about this. And so, I'll just describe it a little bit. So the DNS proxy, basically the idea is that, a device that wants to do this discovery asks the SRP proxy using multicast DNS, do you have any service discovery, any local browsing domain for services that I can use DNS on? And the SRP proxy says, why, sure, I do. Here you go. And sends a PTR record with that information. And then the device establishes a DNS push connection with the SRP proxy, and it says that it wants to look for, say, hap.tcp. I've been using that all over the place. And device B happens to do hap.tcp, and so it registers with the SRP proxy. And then as soon as it's registered with the SRP proxy, the SRP proxy tells device A, which has that open DNS push connection, here you go. So the open issues, as I said, SRP replications, I think it's pretty solid, but it could definitely use more eyes on it. I'm sure there are things I haven't thought of in there. And also maybe it's too complicated. So be nice to have, the working group look at that. And then zone discovery, there are some issues that are sort of unresolved as yet. How do we agree on a domain name? There are some ideas in the draft for how to do that. And also, like, yes, we want this to work in a sort of a permissionless environment. We also want it to work in a more managed environment, whether it's sort of autonomously managed or whether it's managed by a network management team. So that's kind of some stuff that needs to be fleshed out in the document. Again, obviously it's a little soon for the working group to say yes to these questions. I'm just announcing that this is something that I would like the working group to consider once people have time to read these documents and figure out whether they think they're worth adopting. Obviously, it's premature to ask to adopt right now, but this is something that I would like to see happen. Personally, I'd like to see it happen really soon because I'd love to see, work done on these and for us to make progress on this stuff. So I don't know. I don't know if there's really a need. Barbara, do you think we need to actually ask the working group a question right now? I mean, I'm not really asking for immediate adoption. I'm just saying let's and I'll send some mail to the mailing list and ask people to review this. So.
Yeah, I think that's enough. You're
Okay.
just introducing it.
Yep.
Yeah, let's get the drafts published and give people some time to review them, and then
They are published now, finally.
Okay, yeah. Well, as of yesterday, I suppose, when it reopened.
Exactly. Yeah. No. I mean, obviously, it's too late for anybody to review them before the meeting.
Yeah. So yeah, please email the list and asking for reviews, and if we have enough interest and reviews, then that makes us want to consider adoption. But we'll want to see if there's interest from various folks before we do.
Okay. All right. So we have about 3 minutes left of the time slot that you proposed. So I just wanted to talk about some of the remaining issues that I think would be nice for the working group to work on, and that we're certainly thinking about and working on. Stuart and I and some of the other folks on the Discovery team are working on. Currently, we're still very reliant on MDNS, and we can't totally fix that, but it would be nice if we could at least describe how, say, a stub network resolver, like a thread network resolver, excuse me, could, in principle, announce the availability or register the availability of the stub network discovery service to some kind of central authority like your customer edge router or some other device in the home that's managing the DNS in the home. So this kind of is now straying into HomeNet land. Although, and maybe actually this should be something that's done in HomeNet, but I'd like to see it done somewhere in the IETF. So we'd like to be able to do that. We'd like to be able to get away from using multicast at all on Wi-Fi, really, except to support legacy stuff. And we'd like to. One of the things, there are some multicast DNS, like site-wide multicast DNS hacks that various companies have released that actually break MDNS on local links. And it would be nice to be able to just bypass that crap. So being able to set up a DNS infrastructure that does the right thing would be nice. So those are kind of motivations for moving away from MDNS. What we're going to need is, as I said, the ability to register stub network DNS resolvers, to be able to tell devices that service discovery is available. They don't have to use multicast on this particular link, right? And to have all services, not just stub network services, check to see if SRP is available and use it if it is. And then this is a kind of a big ask, and I'm not sure how doable it is, but it would be nice to think about whether we can describe how to do this, and I think we can, which is that it would be nice if, suppose you've got a device that supports multicast DNS only because it's a legacy device, and it's connected to your Wi-Fi network or to your Ethernet, and you'd like to be able to do discovery on that device, and you'd like other devices to be able to discover it, but you don't want to screw up the MDNS service. You don't want to screw up the other devices that are listening for MDNS packets on the network. So what you really want to do is arrange to get an MDNS packet to that device, asking it if it has that service, but you want it to really be a unicast. And obviously, if it's on Wi-Fi, unicasts are actually, multicasts are always unicast towards the Wi-Fi access point. So if you can receive that multicast at the Wi-Fi access point and have a special rule that says whenever you get a multicast of this type, you send it here. You don't just re-multicast it. Then essentially we can get rid of all of the multicast on the Wi-Fi network while still supporting legacy devices. So that's kind of, the last ambition that I wanted to mention here. I'm sure there are other things we ought to do to complete the Dnssd architecture, but these are the things that I have on my list. So that's the end of the slide deck, and we are a minute late. Sorry. There it goes.
Because I did give Torlis an extra 5 minutes, and so you're actually.
Oh, that's right. I'm ahead.
You are. I didn't want to let you know that though before you were finished because.
Right. Well, hopefully I didn't hurry so much that people didn't get what I was saying, but I don't know. We'll see.
So it does look like Torlis has a comment.
Yeah, so I mean the better enterprise level Wi-Fi access point already should be constraining multicast to only the members that do IGMP and then unicast them out instead of doing link local multicast.
Yeah,
right?
yeah.
So
yeah, right. It's like
maybe your problems are already solved with better Wi-Fi access point, and not sure how much more is needed, except for giving BCP recommendations or something. I'm not sure.
No. No. Sorry. If you look closely at how MDNS works, it actually relies fairly heavily on the fact that everybody can hear multicasts. And it tends to fall over in various ways if everybody can't hear the multicasts. And so you have to be really careful about how you set this up. So yes, you're right. In environments where you have Wi-Fi access points that have this functionality, that's awesome. You can set up that IGMP setup and direct it to the discovery proxy, and everybody's happy. But remember, it has to go both ways. That's one thing. And you have to describe how the discovery proxy behaves in that situation. So yeah, you're right. I mean, I don't think that this is a super heavy lift for that type of device. I'd also like to see it on home gateways, though, and those devices might require a little bit more. It may not require specification work to speak of. I don't know. I'm not stating an opinion. I think the working group should look into this and figure out whether it requires, how much work it requires and what work it requires, and then we can either decide to write a document or conclude that there's no work to do, and so we don't have to write a document.
I want to add something a little bit more to what you were saying about that last point, Ted. There are enterprise access points that do, I didn't catch who asked the original question, but it doesn't matter. There are access points that do that, and they completely break multicast DNS. And somehow they ship them anyway and don't seem to have noticed that they've broken it. And the reason they've broken it is one of the efficiency mechanisms in multicast DNS, because multicast on Wi-Fi is so expensive, it's sent at a low data rate, and it can't make use of MIMO because it's just not targeting a single station. Stations listen for each other's queries and answers. So if Ted is looking for a service and the service answers, I see it. Similarly, to eliminate stale data without rapid polling, if Ted queries for a service and I don't see the answer, then I delete it from my cache, because if it was there, it would have answered and I would have seen it. And these access points that do the link layer filtering so that the answer only goes to Ted cause every other device on the network to delete that entry. So they completely don't work. And it just boggles the mind that they sell this to customers and the customers somehow don't notice that now they can't find the printers anymore because of this feature.
They do, and we get a lot of bug reports. Like, it's our biggest source of bug reports.
Yeah, it is.
And it really sucks. I mean, we really like to solve this problem. Anyway,
well, we are over time.
That.
Thank you, Ted.
Yeah.
So, David, do you want to do a wrap up?
Yep. So thanks, Ted, for the presentation. Let me press the, there we go. So yeah, thanks everyone for a good Dnssd session. It sounds like we have some good action items to make progress on several documents. One last important announcement that makes me personally very sad. At the end of this session, Barbara is stepping down as chair of Dnssd. So I would like everyone to please join me in a round of applause for Barbara, and then she can say some parting words. Thank you for your multiple years of service. It was great co-chairing with you.
And so, yeah, I'll be around still through the end of the year, but I am stepping down as chair so that, you know, we can do a graceful transition and hand over to somebody else who, you know, maybe I should give Eric some time to talk about that. I don't know.
No, it was mainly to thank you again, Barbara, on this one, and as well the other HomeNet, where you are also co-chairing, even if it's not meeting today. So thank you for being there. Basically, I'm trying to look for a Mission Impossible, I would say. Find a substitute on alternate server as a working group chair for this working group. So if somebody wants to experiment and basically try to get a working group chair position to learn more about the IETF, it requires some time, but it's not a big amount of time. So feel free to talk to David or Barbara or myself. I'm really welcome a newcomer, typically, right? So not an old guy, a new guy.
That would be a great idea to have a new person join. Dnssd was my first working group, and also now I also chair another one and have taken up way too much work, but that's, I guess, my fault. But I'll say that Dnssd has been a great working group that doesn't have drama like some others, and so it's a great place to start where people are actually doing useful work that lands in billions of devices, and that is fun. So if you're interested in seeing what this side of the IETF is, please reach out to one of us, and we're happy to chat at any point. So just drop us an email and we can chat. All right. On that note, I think that's, unless anyone has final things to bring up, I think that's a wrap. Thanks everyone for coming, and see you on the mailing list. There's going to be some docs to review. All right. Cheers, everyone.
Thanks.
Cheers.